Okay, everyone, another day, another dollar. So I'm going to show you how to extend these wires, where I ended up placing the power pole block. It's a little bit too far away. I mean, that's okay. Gives me another project to show you guys. So I'm going to use two different methods to extend these wires. The first is going to be crimp. So I would not use the insulated terminals. These things are huge. Well, huge compared to the uninsulated terminals. And these things are just barely bigger than the thickness of the wire. So I've got to wrap these in shield, braided shield. So I can't use anything that's pretty thick. The second method will be solder, and huge debate over crimp versus solder, and generally speaking, I would not be using solder on stranded wire. It creates a stress concentration where the solder stops wicking into the strands, and any little movement is going to act like a paper clip. You know, and you bend a paper clip enough, it's going to break, right? So, I mean, you're going to put heat shrink over it anyway, which provides some strain relief. And the larger the wire, the larger the diameter of the wire, the less that heat shrink is going to provide the proper strain relief, and you're going to have to get into clamping. So on these small wires, I'm kind of okay with soldering with heat shrink. Larger wires, basically a crimp only guy. But I do want to show you guys the differences between crimping and soldering. So this uninsulated butt connector is meant for 18 to 22 American wire gauge, maybe 20 to 22. You'll see that kind of hole or dimple in the top. Usually two reasons for that. Number one is to tell you when to stop inserting the wire, so you can only insert it halfway to give the other wire coming in from the other side a chance. Also, on some of these things, it tells you where the top of the crimp is. I don't think it matters on these. You're basically just crushing this sleeve. It doesn't have a seam. So, yeah, let me go ahead and show you the crimp tool. So, just a pair of wire strippers with the crimps right here. Now, I'm too lazy to get out the proper crimp tool with the dies, but this is, these crimps are very basic. You're just kind of crushing that thing. So this is more than adequate. Once you get into like larger sizes or insulated terminals, you really want to get the proper crimp tool with the proper dies. And there's two settings here, 22 to 18 and 16 to 10 American wire gauge. So what I had laying in my stock was some aviation mil-spec wire, 22 gauge. I thought I had 24 gauge laying around somewhere, so this is a little bit big compared to what's on the motor, but it'll work. And so I've already kind of stripped it and cut it to where it needs to be. Maybe I'll just like cut it back a little bit more to reduce the amount of exposed wire out of the crimp. Yep. All right, so I'm going to get it set up like that, and then I'm going to insert it from the other side. After I get the loose strands dealt with. Okay, so it's in as far as the insulation. Well, the insulation is going all the way up to the butt splice, so that's good. So I'm going to go ahead and just give it a good squeeze. Yeah, so basically just flattens it. Always give it a tug to make sure you got a good crimp. Okay, now I've got red wire for the red wire, but I couldn't find any black wire just laying around, so I'm using blue. Also, because the motor leads are thinner gauge, I'm gonna bend that over, double it up to give more wire for the crimp to bite into. So going to, now I should stop here. If you don't have an open end on the wire like here, you want to get your heat shrink over one of these wires. Otherwise you'll never get heat shrink on after you do the crimp or solder. But since I've got an open end after I do the crimp, this is not a problem. So I'm going to worry about it later. Okay. So I'm just going to squeeze again. And don't want to tug too hard because remember, this wire is really thin. So the crimp might hold, but the wire might break, mechanically break because you pull too hard. So it's not going anywhere. And when I'm done with the solder joint, I'll go ahead and show you how to do the heat shrink. All right, so I'll just take you over on the tripod. So here's my Weller soldering iron. With a wet sponge, and explain a little bit about soldering. So soldering is about having enough heat at the right temperature. Heat and temperature aren't the same thing. So you can be at the right temperature but not have a lot of oomph behind it, and you'll never get the joint hot enough. You know, make sure you got the right size soldering iron for the job. So next thing I want to just briefly talk about is there's already solder on this. Whenever you turn it off, or just before you turn it off, you want to kind of clean off the tip to get all the oxidized solder off and oxidized junk off, and then immediately put a fresh coating of solder over that, then shut it off. And that's going to protect the tip from oxidation. Oxidation is bad because it stops heat transfer. So Yeah. Next thing is solder types. So this is 6337 rosin core, much better quality solder than like this stuff. This is the old 6040. This is much easier for beginners to use. It flows a lot better. And it kind of, as it's cooling off, it goes through like a two-stage cooling process or phase transition. The first stage looks like a wrinkle, like a surface wrinkle, and then it hardens. The 6337, and those are just the proportions of lead and tin, or whatever metals they're using now. Yeah, just a small difference in the percentage of elements really makes a huge difference. So for beginners, get the 6040. Everyone else just be using the 6347. This stuff's thin enough where just break off a piece. And then what I'm going to do is over here on the sponge, just clean off all that old stuff. See, it's a lot shinier now. You get it re-tinned. And I'll do that again just before I come back over here to do this. So let's see. Oh yeah, here's the red. So I'm gonna strip a little bit more length off the red. I'm gonna zoom out so you guys can see better. I keep missing the camera here. So I'm just gonna twist these together so there's a mechanical connection, good mechanical connection. All right, then I'm going to solder those after I get my little third hand set up. I'll try not to get in your way. So I'm just cleaning off the tip again. And let's see, I'm putting a fresh coat of solder on it. And the reason is not oxidation, but solder transfers heat a lot better than just the tip itself. And what you want to do is heat up the wire. So I'm just going to put the iron on the wire, and then you're going to use the hot wire to melt the solder. If you melt the solder with the iron and try to drip it on the wire, you'll end up with a cold solder joint because the wire is cold, and it'll immediately harden the solder before the solder gets a chance to penetrate. So yeah, that's good. All right. I'm just cleaning the tip off again, applying fresh coat of solder on the tip. So I'm tinning the solder tip. I'm going to shut the iron off. Okay. So to deal with this, I'm not going to put heat shrink over it like that and have the wires like stick out like that. What I like to do is bend the wires over like that and then put heat shrink over it. Okay. And also in this application, I'll never get the shield, the wire braid shield over it if I do it the other way. So, all right. time for heat shrink. So that's probably good enough. Okay, so that's a little bit too small to get over that solder joint. Let's see if it'll go over the crimp. Yep. Just like to feel around a little bit to make sure the heat shrink is centered. Let me find a slightly larger tube, like maybe this, for the other one. Just feeling for where the edges are. Okay. We'll zoom you guys back out. Creme brulee torch. You can use a Bic lighter. These wires are super thin, so you don't want to spend a lot of time getting the heat shrink shrunk. Also, you want to know, we're kind of like shooting. You want to know your target and what's behind the target. So I don't want to melt anything that isn't supposed to be melted, so I'll just use an aluminum heat shield. This first one will go pretty quick because it's pretty thin-walled. This next one might take a little bit more. It's a thicker piece of shrink. All right, good enough for government work. So there you go. Next step is dig out the shielding wire, the braided shielding wire, and I'll show you how to get it over these wires, and then you'll need an extra bit of length to bond it to something. I'll show you how to get that extra length and also get these wires out of it. Yeah, one thing, you'll never get these wires through the braid if you got them stripped. So there we go, problem solved. You'll see why eventually. All right, be right back. All right, camera app crashed. So this stuff's like Chinese finger trap. If you pull it, it just gets tighter. But if you push it, it'll open up. It's on a bias, so if you push it, you'll see it open it up, right? And that's how you easily get it off. So here's the thin stuff. Here's the thickish stuff. It also comes in sizes that big, even bigger, intermediate sizes. Used mostly for bonding straps. Here I'm using it as a RF shield. So I want to get the length right. So here's what I'm going to do. I'm going to just kind of trace this out along the wires. well, forget about that. So I'm going to trace it along the length, the path that I'm going to put it on. All right, it's going to probably loop up around here like this into one of the power pole slots. And then you need an extra bit of piece to run down to a bonding point. That's how the RF energy is going to travel along the shield and dump into the negative side of the power bus. All right, so there's a bonding point right here. Well, I'm going to make it long enough to go to this other one. All right. All right. So that's my length. I'm going to make it a little bit longer because this stuff's on a bias. It's not going to be this thin on the wire. It's going to be expanded because it's on a bias. When it expands a little bit, it's going to shorten. So I'm just going to make this stuff a little bit longer than it needs to be. And probably the easiest way to get wires through this stuff is put some heat shrink around it. And what you're trying to do is press this open so you can get the wire into the center, okay? So it looks like that. Remember Chinese finger trap? Pushed together, it expands. All right. Oh yeah, I gotta put that heat shrink on. I want to make sure I got the right piece, so before I do all that, yeah, that's the right piece. I'm going to shorten this up a little bit. Oopsies. Oh, the heat shrink came off. All right, well, I'll get another piece on. All right. It's going to be a pain in the butt, isn't it? All right, I'll try some dielectric grease, help get it over. One wire at a time, I guess. Now back to this. Pretty much destroyed that end beyond reusing it, so you can also use like a peck to get this started. Yeah. some point you're not going to be able to shove it in anymore, and what you need to do is do the Chinese finger trap thing. Oops. Poked out. Dang it. Okay, future me here, guys. Realized I wasn't explaining what was going on here, but imagine this pen is the wire inside the braid. Okay, what I'm doing here is I'm taking the free end and I'm pushing it onto the wire, and as I'm pushing it, that Chinese finger trap expands. So I'm getting a bunch of expanded braid right where the wire starts. And then what I do is I clamp it with my finger, and then I take my other hand or fingers and I take the material that's built up and I do the opposite. I pull it. So I push it on to get material on. When I push it, it loosens it up. And then when I pull it, it slides along the wire and tightens back up. And I just keep doing this like worm kind of motion. Push it on, push it to expand it to get it on, pull it to slide it down the wire and make it grab the wire again. I just keep doing that over and over again. As you kind of open up one end, you want to slide the rest down the wire, otherwise it'll start bunching up. And I'm starting to get close to the end here. All right, I gotta flatten this out as much as I can so I can get this heat shrink over it. So this ain't gonna work. That's okay. I'll just use put this heat shrink under the braid. I'll put another one over. Thought that might happen. I'm gonna put a little bit more length down, and that smaller piece of heat shrink is going to help protect the wires from the heat down there when I heat shrink it. Alright guys, pulling that braid back. Otherwise, it might make it hard to shrink it. Alrighty. Okay, looks good. Now what I'm going to do is pull the excess back down. So I'm just threading it where I want it to go. And actually, I'm going to just use all the... Let me show you better. I'm just going to use all the wire. Okay. And it ends right about here. You don't want to pull a lot out, but you need to pull enough out to do the crimping for the connectors. All right. So I'm going to guess right about here. You want to open the braid up. Okay. You're going to kind of get under those wires. And you're going to pull these wires out. And I suppose you could just leave that heat shrink in there. Yeah, I'll never get that out probably. And so the rest of this will just run to a bonding point, and I'll trim it to the appropriate length when I get there. All right, so now I got to do the power poles. All right, since these are 22 gauge, I do want to double them up inside the terminal. So I'm going to strip it a little long. Remember, I did red to red and blue to black. Just gonna make sure that these things do indeed fit in there. Yep. Alrighty. And you just got to remember, when you insert these, negatives on this side, positives on the right side, looking from this direction. So I'm going to go ahead and crimp these. Ow! Damn it! There we go. What I'll probably do is run some heat shrink over this just to hold it tight so that the shielding doesn't back off too far. Running into a little problem, no big deal. There we go. And I'll get those inserted into the power poles before I heat shrink that. Sorry. You guys can't see a thing, can you? There we go. Sorry you guys aren't seeing this. I gotta finish this project up. I'm tired of trying to find good camera angles. Alright, so I'm just going to shrink it like that, okay? Man, my goddamn allergies in my voice. Alrighty. Alright, and that's about the length I need to get a nice service loop to that stud right there. So, going to cut it Go look for my uninsulated terminals. So I got pins. I got uninsulated terminals. That's probably what I'll need. Let me get the ring size right. Got the ring size right. Okay, that's the right ring size. And it'll slip in just like that. And then we'll crimp it. All right. Again, I'm just going to use these things. All right, so you're poking through. You don't want this thing like poking all the way through. Just like make it so it's just flush with the opening. And you can crimp. All right, not going anywhere. Just gonna undo this. So I made this so I can do this. All right. Put the washer on. All right. All right. So this is the fan wires. It naturally just wants to do that. So I'm gonna put a clamp and hold it, put the clamp on that stud and hold the wire like that so it doesn't like break eventually. This is called an 8L clamp, wedge type. You can see the wedge. Where's the wedge? Yeah, there you go. Right there in the lower part of the wrench. That's so the wire doesn't get caught in the tabs here on the clamp and crush it. So that wedge is supposed to help keep the wire in place. They make versions that don't do that, just straight up clamps, and they make versions with just the well, without the rubber, and that's good for like aluminum too, for like brake lines and fuel lines. So I'm gonna undo this. All right. So just gonna slip it in. There we go. Just gonna kind of close it with my fingers. Yeah, just need to get a few threads going or exposed. This is the smallest clamp I have, and it's still a little loose, but good enough. Just trying to keep the clamp in place while I tighten it. Make sure it's not going to go off at a weird angle. All right. Actually, that's not too loose. That's actually tight. So, or tight enough where the wires are going to go any place. All right.